And welcome back. And as was mentioned earlier, today is
World Meteorological Day. And of course, we're going to go in our time capsule and go back to 2009.
Yeah.
When Marlene visited and did this particular story. It's just a good reminder of the work that the Met Service does for the country.
All right, so let's take a look back at my visit at the Met office in Ladyville. Sunny, windy, cloudy, rainy. Those seem to be the easiest ways to tell the weather. But we depend on our weather forecasters every day to be able to tell us on whether or not to pack an umbrella or a light jacket. But there's so much more that goes into forecasting the weather than looking up at the sky. So we're here at the National Meteorological Service to be able to find out what really goes into putting a forecast together.
Good day, sunshine. Good day, sunshine. Good day, sunshine. I need to lie.
We're here with Acting Chief Meteorologist Dennis Gungas, and he's going to help us to understand the process that you go through in putting together the weather forecast.
Yes, I'll show you the exact steps we go through, starting from the first time the forecaster arrives at the office until his day is complete.
Okay, let's find out. What's the first thing that they have to do?
Okay, the first time forecaster comes to the office, he speaks to the forecaster that was on duty earlier to get a briefing of what the weather was like and what that forecaster is expecting the weather to be in the next 24 or 48 hours.
Okay.
So he gets a weather briefing from the forecaster that was on duty at the time, right? From there, you go and you look at the bigger picture. You go to your satellite pictures, and you look to see what is around the region. Okay. And if we could just look at our satellite picture over there,
okay.
That gives us a broad picture of what is occurring around the region. And you can see here that not much is going on in the Caribbean or the Gulf of Mexico. It's been a rather quiet hurricane season so far. This here is like, for example, a tropical wave that's heading into the Eastern Caribbean. But besides that, we could see that there's not much else happening.
Now, you use websites or satellites from off the internet.
Right.
Okay,
right.
connecting to other systems.
Right.
Now, if I look at this, when I see these areas, I think this is rain and this is all sun. Is that accurate?
To some extent, the brighter colors are the more intense, convection, where it's quite likely there are rain or thunderstorms occurring. However, we'd have to go to our observations, or actual observations, for example, from the island of Trinidad out here, to find out whether it's actually raining underneath those clouds. So you can just infer that it's raining from the pictures. You cannot tell. You have to go to the actual observation to tell what is happening on the ground. These charts are actual observations. This is analysis from the surface, what's happening at the surface. This is at 5,000 feet up in the air, 10,000 feet, 15,000 feet, 30,000 feet, and 39,000 feet up in the air. Whatever happens at the surface is largely controlled by what is happening above us. So we need to know what is happening above us.
Now, it almost looks like a 3-year-old that had these pictures and drew lines all over them. What are the lines indicating?
Yeah, it has meanings. It has significant meanings to us. These indicate how the winds are blowing at that level.
Okay.
Right? It's blowing out. This is an anticyclone. The wind is blowing out here and heading in this direction. That's how the wind is blowing. And the wind is going into this point. So this is a cyclone here, heading into this point here. A cold front entering the Gulf.
This is the cold front?
Right. It's demarked by this line. Right. A cold front entering the Gulf. The front coming down a little bit closer to us, and the front has passed us on Sunday.
Okay.
Right.
But you don't know what type of weather this front will bring as yet.
Again, that's where experience comes in. It
Okay.
tells you, like, if a front comes and sits right over us, it's quite likely you're going to get wet.
Okay.
Right? In addition to that, we also have forecast charts that show us rainfall.
Okay.
Right? And again, that gives us a little bit of guidance. Yeah, we're slowly integrating the Doppler into our forecast process. And this image here is at 400 kilometers. That's about 250 miles range.
Okay.
Right? At that point, you're mostly seeing the top of the clouds because of the curvature of the Earth. the radar is looking that way, and because of the curvature of the Earth, you're seeing the top, basically the top of the clouds at 200 kilometers. However, we can see that there is some convection over the Yucatan Peninsula there, right?
So this center point here is where we're at right now.
Right. The basic principle behind the function of our radar is that you have an antenna that sends out radiation, and that radiation hits off cloud particles. If the cloud particles are large enough to fall out of the cloud as rain, then that radiation is reflected back to the antenna. So while the antenna is here, it's sending out radiation. It hits the cloud particles. The radiation hits the cloud particle and bounces back to the antenna. Sorry. And while the antenna spins, it is sending out radiation, pulses of radiation. Okay. So it sends out a pulse. It waits for a return signal from the cloud. And if it doesn't get any return signal, then that means the droplets are not big enough to fall out to form rains. Okay. Right? And the antenna spins, and it spins at different elevations. It goes at a horizontal elevation, then the next scan it goes about a degree up, and scans at a degree up, then it goes another degree up until it reaches a vertical position. Then it starts another scan coming down. Right. The antenna is in there. The big antenna is in there. The electronics part is in just below the antenna there.
Now, it was said that at the point when it was installed that it would have a large impact on the time of threats of hurricane. Why is that?
Right, because we have been depending on satellite pictures, and there's a time lapse in between receiving our satellite pictures, somewhere around 10 to 15 minutes. Our Doppler radar gives us instantaneous images. We know at 4 o'clock this evening, the tropical storm will be at that point, and we know 5 minutes later where it will be because we have our live images coming into us. While the satellite picture, there was a delay in receiving the satellite pictures. Each hour, at about 10 minutes before the hour, the meteorological assistant comes down, and he or she comes to this plot here and does a meteorological observation. This is done worldwide at the same time. The Stevenson screen houses our thermometers, and it is louvered to regulate the airflow over the thermometers. Here we have what we call a regular dry bulb thermometer, and that's our wet bulb thermometer. You can see it's wet. We call it wet because there's a string attached and it's constantly being kept moist. Okay. Together, they give us the relative humidity, how much moisture is in the air. Okay. Here we have our maximum thermometer, which gives us the highest temperature for the day, and the minimum thermometer, which is the lowest temperature. The highest temperature occurs just about now, around this time. Right, about 2:30 or 3 o'clock in the afternoon.
And this is 32?
Right.
32 degrees.
Right, that's our highest temperature so far for the day. So we get the temperatures, we get our visibility, we get the clouds. For example, how much cloud, what type of clouds, how high the clouds are. In this plot here, we have, this gives us our average wind speed at about 6 feet. Average wind speed at about 6 feet. This is measured every 9 o'clock in the morning, so we get an idea of what was the wind speed in a 24-hour period. The other instrument we have here is our evaporation pan, and like the name indicates, it measures evaporation, the rate at which the sun and the wind removes water from an exposed surface. Okay, this instrument here is a solarimeter. It measures the intensity of the sun's rays. You see the black dot there? We know how black absorbs all the heat energy. So all the sun's rays are focused on that black dot there, and the intensity of the sun's rays are recorded on an instrument up in the office there. This is our sunshine recorder. How it works is it's a ball that concentrates the sun's rays, and it burns a card. And as the sun crosses overhead and heads over the other direction, the card burns from one side to the other side. If you just look over here, you could see the card burning, right? And with that, we can get the hours of sunlight. Here we have our standard rain gauge. Our rain gauge measures how much rainfall we receive. And how it works, we have the rain falling into this container here, and then there's a funnel, and the water goes through the funnel into a bottle. It's collected into a bottle. Then we pour out the water to see how many inches of rainfall we receive. And if it rains too much and it overflows, right, and we haven't seen that quite often, then we have this to catch the overflow. Okay. Right. If this bottle overfills before we can measure it, then we have this to catch the overflow.
How often is this measured?
We measure rainfall every 6 hours.
Okay.
We have a couple of our soil thermometers. They measure the temperature of the earth at different levels. They're basically for agricultural purposes. This is a soil thermometer at 1 foot into the ground, right? And what it gives us the temperature at certain root zones for particular plants.
Okay.
Okay. So we're more than just forecasting the weather. We have other interests, including agriculture, flood forecasting, climate. That's 1 foot, and there's a 4 feet thermometer over this side here. That's right. Up on the tower there, we have our wind vane, and you can see it has a wind direction, north, south, east, and west, and it points in the direction that the wind is blowing from. Okay. And the cups that are spinning gives us the wind speeds. Okay. So you know if the wind blows faster, then you see the cup spin faster. Behind here is our pump house where we generate our own hydrogen. We have our own hydrogen generator here, where we take, for those of us who love chemistry, we take water, H2O, and we split the water, and we throw away the oxygen. We don't want that, and we store. We generate the hydrogen here, and we store the hydrogen in that tank there. Attach a nozzle onto the balloon. We fill the balloon tight. Attach one of these parachutes onto it. Attach the instrument under it, and then we release it. Right? And it automatically goes up, and it goes up for about, like I said, an hour and a half, 2 hours. The balloon breaks. All that while, it's sending back information about the wind direction, wind speed, how much water is in the air, and temperatures and things like that. So, and then again, I explained to you about the international commitment we have. We have to take that same information and transmit it to the rest of the world likewise. We have flood forecasting capabilities. We have a hydrology unit that deals with flood forecasting. We have a climatology and climate change unit that deals with climate issues. So we're branched out to more than just the forecasting part of the department.
Okay. All right. And what part of it excites you the most right now?
Well, I'm in charge of everything, so everything excites me about it now.